Hi, this is Nimla Rednam. In this video, I'm going to start the topic Direct and Inverse Proportions, which is the 11th chapter from NCERT textbook class 8. In this chapter, we are going to look at different scenarios and we're going to identify parameters and try to understand the relation between any two given parameters. Given the, whatever is the information given to us, we are further going to try to find out one of the parameters if the other is known to us by looking at the relation between these two parameters. Now let us start with an example. You are already familiar with the formula speed is equal to distance by time, right? I'm using the formula from your physics. Speed is equal to distance by time. Now let us hold one of them fixed. Okay, for example, I have a fixed speed, that is my walking speed is fixed. Okay, you go on a walk in the evening, right, and you have a fixed walking speed. Then if you have to cover more distance, what time is it going to take? Is it going to take the same amount of time, lesser time, or more time? That is what we are going to understand. That's the relation between the distance and time here. Naturally, you can understand that you're going to take more time if you want to cover more distance, considering that your speed is going to be the same, right? And if you're decreasing the amount of time you're spending in walking, then naturally your distance covered is going to reduce. Correct? So you can see here that distance and time are going together. That is, they are moving in the same direction. That is, if one increases, the other increases. If one decreases, the other decreases. Now, this trend, along with the confirmation that the ratio is always a constant. Now this here k speed is a constant, right? If the ratio is always a constant, then we say that they are in direct proportion. That is the meaning of direct proportion, that any two given parameters or variables are, the ratio is always the same. Then they are said to be in direct proportion. You can think of many examples where you get to see, that the two given variables are in direct proportion. Next, coming to inverse proportion. Now, let us say that I have distance constant. That is, I have a fixed distance, right, from point A to point B. The distance is fixed, right? Now here, if I increase my speed, the time taken to reach point B is going to decrease. It's quite understandable, right? That if I walk faster, I'll take lesser time to cover the distance. And if I reduce my speed, it's going to take me more time to cover the same distance, right? So here you can see that the variable speed and time, these two parameters are moving in the opposite direction. That is, if one increases, the other decreases, and if one decreases, the other increases. This trend, along with the information that the product is a constant, okay, is nothing but your inverse proportion. Okay, this is nothing but inverse proportion. So here, in case of direct proportion, two variables x, y, for any 2 points 1 and 2, you can always write x1 by y1 is equal to x2 by y2. Whereas for inverse proportion, x1 into y1 is equal to x2 into y2. That is all we have in this chapter. We will be given a scenario. We have to identify. First thing you're going to do, first step is you're going to identify the variables, right? And then you are going to represent the given information in the form of a table, and then you're going to decide whether these two variables are in direct proportion or inverse proportion, correct? And then you're going to calculate whatever they have asked for. That is all we will be doing in these two exercises. Now here, what I have noticed is usually what happens when the students are in the first chapter blindly, they're going to assume it is direct proportion. First exercise, they're going to assume it's direct proportion and apply the formula. And in the second exercise, inverse proportion and apply the formula over there. So in the exam, you won't have that advantage because you don't know which exercise the sum is from and so on. So what I'll be doing is, now for this chapter, I want to randomly pick four to five sums and I want to solve them, so that when you start the question, you don't have an idea whether it's direct or inverse proportion. You have to decide whether it is direct proportion or inverse proportion depending on what is that scenario that we are considering, right? So I'll read out the first question that I picked out. A farmer has enough food to feed 20 animals in his cattle for 6 days. Okay. How long would the food last if there were 10 more animals in his cattle? So first I have to identify the variables here. They're talking about, clearly they're talking about number of animals. You can see that they're talking about 20 animals, 10 more animals added, so on. So that is definitely one variable, right? That is one variable. So a farmer is feeding his the animals in the farm, in his cattle, okay, and initially he has enough food to feed 20 animals for 6 days, right? So I'm guessing number of days is the other variable, right? For 20 animals, okay, the food that he has, which is a constant, it's enough, sufficient for 6 days, right? And then they're saying if there are 10 more animals in his cattle, okay, now 10 more animals in the cattle implies there are 30 animals. Then the food is going to last for how long? That is the question. So the first step is identify the variables. We have done that. Number of animals and number of days are my variables. And the table, I already have the table. You just have to draw the lines over here. And then we are going to decide whether it is direct or inverse proportion. Now you can see that if I have more animal to feed, then the fixed amount of food that I have is going to last for lesser days, correct? Because the food is not going to, is the constant here according to the question. The food that the farmer has is fixed. So if I have more animals to feed, it is going to last for fewer days, right? So that means we are talking about inverse proportion. Inverse proportion means the product is constant, correct? So therefore I have x1, y1 is equal to x2, y2. And from here I'm going to write 20 into 6 is equal to 30 into y2, and then calculate y2 is equal to 20 into 6 by 30, which is nothing but 4. That means that the food is going to last for 4 days, correct? Right? So next question that I have picked up is, Rashmi has a road map with a scale of 1 centimeter representing 18 kilometers. She drives on a road for 72 kilometers. What would be her distance covered in the map? So here first of all I have to identify the variables. Okay, we are talking about distance clearly. Distance, and in that you have two types. One is the one that is covered on the map and the other is covered in actual. Okay, what is actual distance covered? These are the two distances we are talking about. And on the map, okay, 1 centimeter is equal to 18 kilometers on road, correct? So that is the information given to us. Now if she has traveled 72 kilometers, then what is the distance traveled on the map? That is the question, right? So we have taken care of the first part, right, which is um, identifying the parameters, and then we have the table. Now we have to decide whether it is direct or inverse proportion. Now on the map, whatever we call it scale, right? So if the distance is more on the map, then the actual distance is going to be more naturally. So this is direct proportion. That means we are talking about x by y equal to constant, or x1 by y1 is equal to x2 by y2, right? So let me write 1 by 18 is equal to x2 by 72, implies x2 is equal to 72 by 18, which is nothing but 4 centimeters, right? So that is your answer for this question. Next, I'll pick up one more question. Let us see. A machine in a soft drink factory fills 840 bottles in 6 hours. Clearly, the variables are number of bottles and number of hours, correct? How many bottles will it fill in 5 hours? So let's note down the variables first. Number of bottles and number of hours, correct? So there is a machine that fills 840 bottles in 6 hours. Okay, so in the table, 840 corresponds to 6 hours. In 5 hours, how many bottles will it fill? Now, the machine is going at its fixed pace. So, if you give it more time, it's going to fill more bottles. If it give it less time, then it's going to fill less number of bottles. So, this is nothing but direct proportion, which means x by y is constant, right? And x1 by y1 is equal to x2 by y2. So, I have 840 by 6 is equal to x2 by 5, implies x2 is equal to 840 into 5 by 6, correct? So this will give you the answer 700 bottles. So the machine is going to fill 700 bottles in 5 hours. That's your answer, right? Next, let us take one last question. A school has 8 periods a day, each of 45 minutes duration. How long would each period be if the school has 9 periods a day, assuming the number of school hours to be the same? Now here clearly number of periods and duration of each period are the variables we are talking about, right? So we have number of periods and duration of each period. These are the two variables we are talking about, correct? Now let's write down the given information. If I have 8 periods, then each period is 45 minutes long, correct? And then they're saying if you have 9 periods, then what will be the duration of each period? Now here you see that they have also mentioned that the school timing, okay, the total time they spent in school, the students spend in school is fixed, right? So whatever adjustment of number of periods, number of breaks, duration of break, all these you're going to do, all those adjustments, you have to make sure that the total time is the same, right? That means that if I increase the number of periods, the duration of each period is going to reduce. That is, they are in inverse proportion, correct? So I have 8 into 45 is equal to 9 into y2, implies y2 is equal to 8 into 45 by 9 which is nothing but 40 minutes. So each period duration is now going to be 40 minutes instead of 45 minutes. So that is your answer for the question we are considering. So this is how all the questions in this particular chapter are going to be, and you're going to solve them simply by first identifying the variables and then representing the data given to you in table form, and then you're going to decide whether it is direct proportion or inverse proportion, and simply put the formula, substitute the formula, you're going to have your answer. So with this, we finish the 11th chapter, direct and inverse proportion.